Hello students, I hope you are fine. I am also fine. Today we are discuss about the respiratory physiology. In my last lecture, discussed with you about the physiology and the anatomical overview of the respiratory system. Today we are starting the respiratory physiology. First of all, we are discuss about the parts, which one we discuss in this lecture. In respiratory system, we can discuss the Tracheo Bronchial Tree and the lung volume and the capacity, surfaces tension of the lungs, respiratory membrane, transportation of the gases, and control of the breath. First, this is a structure of the respiratory system. This is a trachea, this is a cornea, and this is two lungs. This one is right lung and this one is left lung. First of all, we discuss that the right lung. Right lung have the three lobes. This one upper lobe, this one is the middle lobe, and this one is the lower lobe. There are the three lobes which are separated by the two fissures. First one is a horizontal fissure and the horizontal obligate fissure, and the second one is the obligate fissure and first one is the horizontal fissure and the second one is the obligate fissure. The right lung base of the right lung is higher than the left lung. Why? Because due to the dome of the left lung is more deeply than the right lung due to the diaphragm. And the upper lobe has the three segments. This one is the upper lobe and it has the three segments, 1, 2 and 3. And the lower and the middle lobe has the two segments. This one is the middle lobe. This one has two segments, 1 and 2. And this one is the lower lobe, and the lower lobe has the 5 segments. In this we only shows 1, 2, 3 and 4. The one is at the posterior side of the lung, which we cannot see in this diagram. Okay, and now we discuss about the left lung. Left lung has the two lobes. This one is the one upper lobe and this one is the lower lobe. Okay, this has the two lobes and it's separated by only obligate fissure. This right lung is separated by the horizontal and the obligate fissures, separated by the two fissures, and this one is only separated by the one fissure. Okay, then we discuss about this one. This one is, what is this? This is the cardiac notch. Because here we have a heart, so that why it's a cardiac notch. Its name is cardiac notch. Is anything you have discussed, you can comment me. Okay, I hope I discussed clearly. This is a cardiac notch, and this lung is divided into two lobes. Okay, first one is upper lobe and second one is the lower lobe. The lower lobe has the 5 segments and the upper lobe has the 3 segments. Okay, then these segments are collectively called the bronchiopulmonary segments. Okay, these segments are collectively called the bronchiopulmonary segments. Now we discuss about the Tracheo Bronchial Tree. Okay, now we discuss about the Tracheo Bronchial Tree. Okay, I hope you understand well. Each Tracheo Bronchial Tree have their own air supply. Okay, each lobe have their own bronchial tracheobronchial tree. This one is the trachea and it is divided into. Now I make another diagram which you have clearly discussed. This one is a trachea and this is divided into right side and subdivided, and its one is the left side and it's divided, this subdivided. Okay, and they have other branches. Okay, this one have and other many branches. Okay, and now this one is the trachea. You know what is a trachea? Trachea is a windpipe. Okay, this is these have a rings. These rings are called the carina. Okay, these are divided into the this is a trachea, and this is divided into two from this side. This side called the carina. Okay, and from this junction it is divided into two, and this one is the right and this one is the left, and the right primary bronchus. Okay, sorry, it is the right primary bronchus and it is the left primary bronchus. Okay, I write in a short words. I hope you can understand. And now it's divided into other. First into primary, then secondary, and then tertiary. Okay, this one is the primary and this one is secondary. This one is secondary branches, and the subdivisions are called the tertiary. Okay, now we can discuss this. These are the conducting zone. What is this? This is a conducting zone. And what is its mean? It is a conducting zone and it's conduct the air toward the respiratory echinus. It conduct the air toward respiratory echinus. And what is echinus? Now we discuss about this. When these branches are subdivided, it has the alveoli. The alveoli are here. This one is the alveoli, and then pulmonary capacities. Okay, this one. Okay, this is the bronchiole. That is the terminal of the bronchiole. I hope you can understand. And then the respiratory bronchiole. And then the alveoli ducts. These are the alveoli ducts. Okay, alveolar ducts, because these are joined with the alveoli, so that's why we ask it's the alveoli ducts. These are the alveoli. Okay, and we have exchanges of gases in the alveoli. Okay, this I can tell you, these are the pulmonary capillaries. Here the pulmonary capillaries, where the blood where the oxygen and the carbon dioxide is exchanged with the blood. Okay, now these all bronchioles, terminal bronchioles, respiratory bronchioles, alveoli ducts, alveoli, and the pulmonary capillaries. In these three one, alveoli, alveoli duct, and the respiratory bronchiole, these three are collectively called respiratory echinus. Okay, and here the gaseous exchanging take place, and here gaseous exchanging take place. Okay, now we can discuss the dead spaces. What is the dead spaces? Okay, now we can discuss about the dead spaces. What is the dead spaces? The volume of the inhaled air that does not take part gaseous exchange is called the dead spaces. The volume volume of the air, friction of the tedral volume that will not be participate in the gaseous exchanging, and it is present in the conducting zone, where it is present in this conducting zone and not participate in the gaseous exchanging, not participate in the gaseous and present in the conducting zone. Now we discuss about the types of the dead spaces. What are the types of the dead spaces? There are the two types of the dead spaces. First one is anatomically. First one is the anatomically dead spaces. I can write it DS, okay? And the second one is physiologically, okay? Physiologically dead spaces. Now we discuss about this. The anatomically dead spaces, in this the volume of the air present in the conducting zone of the tracheal tree, okay, and not participated in the in this the volume of the air, okay, in this the volume of the air only go toward conducting zone and stay there, not participating in exchanges of gases, okay. This one is anatomically dead spaces, okay. And this weight is, if we calculate this, then if we can calculate this weight in pounds are equal to anatomically dead spaces, okay, in milliliter, which this, if we can calculate this, then its weight is equal to the anatomically dead spaces weight in pounds, okay. For example, I have this 401 pounds and is equal to 90 milliliter. 90 milliliter is the dead spaces, okay, and this 401 pound is my weight, okay. Now we can discuss about this is the anatomically dead spaces, okay. This we discuss about first one, and now we discuss about the second one, okay. Second one is the physiologically dead spaces, okay. I hope you can understand. This one is air go toward the alveoli, okay, alveoli and the respiratory acne. I can tell you here what is these three collectively called the respiratory acnes, okay. In this the air go toward the respiratory. Yes, now we discuss about the physically dead spaces, okay. In this physically dead spaces, the volume of the air present in the respiratory acnes and not participated in the gaseous exchanging. In this the volume of the air is only in the conducting zone but not exchanging of the gases, and in this the volume of the air go to alveoli but not participated in the gaseous exchanging, okay. This also cause the pulmonary embolisms. This one we can discuss in the pathology. Next, after this physiology, we can start the pathology, and in this I study about this, okay. Now total dead spaces, how we can calculate the total dead spaces. you know, when we total, we can add this one, sum of the anatomical dead spaces and the physiological dead spaces. Okay, this one. And for all the particle proportional to the totally dead spaces will be equal to the anatomical dead spaces. Okay, particle proportional total dead spaces are equal to the physiological dead spaces. Now we discuss about the right pulmonary bronchus and the left pulmonary bronchus. Here we can make this difference. This is the right pulmonary bronchus and here the left pulmonary bronchus. Okay, now its one is first we compare this. The right one is in right one the bronchus is narrowing, and here the left one is the wider. Second difference is it's more in line with trachea. And this one is more in horizontally. This one is vertically and this one is horizontally. Okay, now the other difference is during sitting or standing position the aspiration of object take place in right lung. What is the aspiration? Aspiration is the inhalation. It's the other name of inhalation. When we inhale oxygen, they ask during sitting or the standing position. When we are sitting or in a standing position, the respiration take place at the right lung. Okay, inhalation, when we inhale air. Okay, and in this, when we are at the laying position. Okay, at the alternate of this one. And the other difference is when we are at the laying position. In right pulmonary bronchus, when we are in the laying position, the aspiration is 50 to 50. Means it's a 50-50 of the aspiration, maybe inhale or maybe exhale. Okay, and in these, the chance of aspiration in lungs when we are in the laying position is 50%. Okay, now we discuss next we in this I hope you can understand very well. Now we discuss about the other this one, lung volume and the capacities. And before this we can discuss about the carina. Okay, now we discuss about the carina. What is carina? Okay, I think I cannot pronunciate it because every pronunciation is changed, so you can understand and according to your pronunciation. Okay, it is a carina. What is this? This when we divided the trachea. Okay, we can discuss about the carina. What is this? This is the when the trachea is divided into the primary bronchus. This one is the right and this one is the left. In this angle it is present. Okay, and they ask the basically it is the carina. Okay, and this obstruction, the inflammation is called the carina. Okay, it is the angle between the right and the left pulmonary bronchus. Okay, and the enlargement of the carina Okay, the angle between the right and the left pulmonary bronchus is called the carina. Okay, and the enlargement of the carina will be the obstruction of the la, uh, of the large airways. Okay, of the obstruction of the large airways. Okay, sorry, larger airways. And these are further we can explain. These have the further two types. Now we can explain these types. Actually it's a difference. Okay, they are the two types of the obstructions. This type of obstruction, first is the smaller airway obstruction, and second one is the large airway obstruction. Okay, second one is the large airway obstruction. Okay, now first we discuss about the common features of this one. In both this one, the patient have the shortness of the breath and the cough. In both of these, the patient have the shortness of the breath and cough. Shortness of the breath and cough. Okay, this is the commonest feature. Okay, excuse me. Okay, this has the common features that the patient have the shortness of the breath and the cough, and the contrasting features are the contrasting or the different features. Okay, different features are the in these the bronchi greater in intensity. Okay, in this the bronchi is greater in intensity and can be heard with the stethoscope. When we hear the stethoscope, the bronchi is greater and sounds like a visual lesser sounds. Okay, and in this there are present stutter or the is in abnormal breath. Okay, I hope you can understand. Stutter is the abnormal breath sound which is present in the large obstruction. Okay, which is present in the larger obstruction of the airways. Okay, I hope you will understand very well. If you have any question, you can comment me, and stay tuned with me. Okay, in next lecture we can discuss about the respiratory membrane. Okay, for next lecture please subscribe my channel, and waiting for the next video. Okay, in the next lecture we can discuss about the respiratory membrane. Thank you so much. If you have any question, you can comment me. I will help you. Okay, Allah Hafiz.